welcome to True Projects. In this video, we are going to explain about the project that is Fish Freshness Detection through Artificial Intelligence Approaches, a comprehensive study. So, before getting into the execution, first let us understand what is the project about. So, fish, that is, it may be fish or seafood. They aren't just tasty, they are packed with nutrients that our bodies really need. We are talking about vitamins, minerals, and those famous omega 3 fatty acids that everyone keeps mentioning. These aren't just buzzwords. Omega 3 is actually helpful for keeping your heart in good shape and lower the risk of sometimes serious diseases. That's why including fish isn't in your diet isn't just a good idea, it is one of the smartest moves for overall health. But here there are some problems. So fish is super perishable. That is, if it is not fresh, it is not just a matter of taste, it can actually be harmful. Spoiled fish can lead to bacteria growth, food poisoning, and a loss of all those great nutrients. That's why knowing how to handle and store fish properly is crucial. From making sure that it is kept at right temperature to recognize the signs of freshness like clear eyes and bright red grills. So there's a lot that goes into ensuring that fish you eat is safe and the high quality. At the end, at the end of the day, fish is one of the best foods that you can eat, but only if it is fresh. Otherwise, it stops being a health booster and turns into a risk. So that is why understanding freshness indicators and proper storage methods is so important because no one wants to deal with the food poisoning when they were just trying to eat healthy. And we do have some traditional methods for this. So, traditional methods, that is, traditionally, people have used sensory checks like looking, touching, smelling, and microbiological tests, that is, checking bacterial growth, and chemical analysis, testing spoilage indicators to assess fish freshness, that is, freshness. While effective, these methods take time, they need experts, and can be subjective. Two people might judge the same fish differently. And here, visual indicators we have. So, visual indicators like eye clarity, grill color, and texture are quick ways to judge fish freshness. Bright, clear eyes, deep red or pink grills, and firm texture usually means the fish is fresh. However, manual inspection isn't foolproof. Lighting and human error can affect the accuracy. So, this is where AI and image processing comes in. AI can analyze fish images and classify freshness with greater consistency and speed, removing guesswork and human error. This makes fish freshness assessment faster and more reliable and easier for markets, restaurants, and food safety industries. So, this project is basically an AI powered model that checks if a fish is fresh or stale just by analyzing its image. So, instead of relying on traditional methods like sniffing, touching, or doing chemical tests, this system looks at key visual indicators, mainly the color changes in the fish grills and eyes. These changes are strong sign of how fresh it is. So, to do this, the system uses some advanced pre-trained models that are MobileNet V2 and exception and VGG16. So these are the models used in this project to to extract the important features from the images. Once those features are extracted, we have some machine learning models that are used. So after extracting the features, we feed those images to the machine learning models that are support vector machine, logistic regression, ANN, and random forest, which take over to classify the fish as either fresh or tail, that is, it is spoiled. So the cool part of this approach is it is not only super fast and accurate, but it is also more practical and cost effective than traditional testing methods, making it useful for business in the seafood industry. And the system is trained using the data set from Kaggle called Fish Freshness Classification, which contains 4,476 labeled images of fish in different freshness states. To ensure it works well, to ensure that it works well, its performance is measured using different metrics that are accuracy, precision, recall, and F1 score, which are standard metrics that helps to confirm how reliable the classification is. And now moving on to the extension. So to further improve the performance, here we have used multiple models to increase the performance. Here we have used exception and MobileNet for extracting the features and voting classifier for classifying the fish stage, that is fish freshness. And additionally, we have also developed detection part, that is localizing the parts of the fish for detecting the freshness. So for that, we have used YOLO family of object detection algorithm that is used to detect abnormalities in fish images, enabling both the freshness assessment and also defect identification. And here we have also developed front end using Flash based application, that is Flash based framework, allowing users to interact with the system while maintaining secure access through authentication. This extension enhances classification performance, enables automatic defect detection, and provides a practical user friendly interface for application purpose. And now moving on to the implementation. To implement this project, we have followed the steps which are mentioned in the flow of work. So we have followed set of steps for classification and other set of steps for detection purpose. So these are the steps followed for classification and these are the steps followed for detection purpose. Let's understand. Let's see how we have implemented the project. So first we import all the necessary libraries for image processing, machine learning and deep learning. And then comes exploratory data analysis part. So here we analyze the fish data set to inspect images and understand data distribution. Then comes image processing. So here we have used image data generator for augmenting images by rescaling, applying transformations, that is shear transformation, zoom transformation, and flipping, and also reshaping. Then comes feature extraction for TL model. So here we read the image, we resize the image, we convert the color, we encode labels of deep learning models. And then comes data splitting part. So here we split the data into two parts. One is training set and the other one is testing set. So here we have split the data into two set of steps. So here first we assign 80% of the data for training and 20% of the data for testing. This is one kind of step. And in the other step, here we will be training all the models on this set and the other set also we have developed. So here in this step, in this setup, we will be assigning 70% of the data for training and 30% for validation purpose. And then comes feature extraction part. So here we have used transfer learning models that are MobileNet VGG16 exception and the extension model MobileNet with exception. And then comes the sixth step. So here we define early stopping to prevent underfitting or overfitting during training. And then we initialize deep learning model for classification. Then comes training the model part. So here we train the model using extracted features and optimize the performance. Then we store the best performing model for further classification of abnormalities. And coming to the detection, so here we import libraries similar to the classification and then comes exploring the dataset part. So here we read and visualize images from the dataset and then comes image processing. So here we convert images into blob objects, we define classes and create bounding boxes. And then we convert images to NumPy array format for processing. Then comes loading pre-trained models. So here we will be loading YOLO-based pre-trained networks, extract layers, and prepare for detection purpose. And then comes further image processing. So here we append annotation files, we convert images from BGR to RGB, we create masks and also resize the images. And coming to data augmentation, so here we apply transformations like randomization, rotation, and other image classification. Then we process the data according to the YOLO architecture. So here we adapt the data for object detection using YOLO architecture. Coming to building the model, so here we construct the detection and then we train the model to detect abnormalities and we store the best performing YOLO model for detection purpose. Coming to the front end, so here we developed front end using Flash framework with the user authentication, integrating registration and login using SQLite. And here in the front end users, they will be able to upload images for classification and for detection purpose. And that will be pre-processed at the backend. It will be fed to the trained model. Finally, outcome will be displayed through front end, detecting the freshness of the fish. So this is how we have implemented. Now coming to the algorithms used. So these are the algorithms used for extracting the features. These three are the proposed models and this is the extension model. And here these are the models used for classifying the fish freshness. So these models, they will be individually. So here these four models, they will be individually trained on features extracted using MobileNet V2, VGG16 exception and MobileNet with exception. Coming to detection part, so these are the models used for detecting the fish freshness. So we have used YOLO V5X6, YOLO V5S6, YOLO V8 and YOLO V9. And coming to the requirements part, to implement this project, we need basic requirements, which are hardware and software. So coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview. Now let's execute. To execute, open the code folder that contains source code files. So let's open the code folder. These are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So first, let's open the model folder. So in this folder, we have the algorithm information that is stored in .h5 files, numpy files, and pickle files that will be loaded into the project code during runtime of the application. And here the data is in output 1 folder and output 2 folder. So let's open the output 1 folder. Here the images are in two subfolders. One is train and the other one is valid. So let's open the train folder. Here we have two more subfolders. So here fish A refers to fresh fish. So these are the images which are used for classifying the images. And here we have spoiled fish. So these are the not fresh fishes. So images which are in train folder are used to train the model, train all the models, and images which are in validation folder are used for evaluating the model. Let's get back. And here we have output 2 folder. In this also we have images split into train and validation. Initially here we have told you that we have split the data into 70 is to 30, right? Wait, I'm scrolling. So here we initially told you that we will be splitting the data in this ratio where in one set we will be splitting the data into 80 is to 20, where in train folder we will be having an 80 and the test folder will be 20, and here accordingly 70 and 30. So here also in one folder it is of 70 is to 30 and one folder is of 80 is to 20. And here in the sample folder we have the images that we will be using in the front end for detection and classification purpose. So coming to static folder, this folder contains CSS, JavaScript, and Bootstrap files which are important for the visual appeal. And here in this templates folder, we have files containing HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here in this YOLO v5 folder, we have the dataset used for detection. So let's open the train folder. So here in the images folder, we have the images that are used to train the YOLO v5 model. So here we have clubbed both the fresh images and the stale images. So these are the images that we will be using for training the YOLO v5 model. So here, these are all the images that are used for training the YOLO v5 model. And the detection part. So here in the detection, we will be localizing which parts of the area are spoiled, and based on that, we will be doing detection. So that localizations, that object locations are in this label folder. So let's open the label folder. So this label folder will have all the files containing annotations or labels for objects in the corresponding images. So here each label file, it corresponds to an image file in the image folder, which provides object locations and classes within the image. For example, the first annotation file, it corresponds to the first image file in the image folder. It corresponds to this folder, this file. Similarly, for the second file, second image, we have second annotation file. Accordingly, for all the images which are in the train folder, that is image folder, that are here we have total 3082 images. So for all this 3082 images, we have 3082 label files. You can observe, right? So here all these label files, they follow the YOLO format. Let's open a file for sample. Here this line represents a detected object. Here this is the object class index and it is followed by bounding box coordinates. This is the x limit, this is the y limit, this is the width, and this is height. Let's close this. Similarly, we will be having all the files. Let's get back. So images which are in train folder are used to train the model, and images which are in the validation folder are used to evaluate the model. Accordingly, we have images in the YOLO V8 and YOLO V9, but they are annotated differently because each YOLO version requires its own specific type of annotations for training and testing the model effectively. And moving on to the app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the model file. And here we have two Jupyter Notebook files. So these are the notebook files which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So here this classification folder, that is this classification Jupyter source file, here we will be loading all the images for classification and we will be training all the models for classifying the fish freshness. And coming to the detection, here we will be loading all the images and we will be training YOLO models for detecting the fish freshness. Coming to signup.db file, this file is database file which is used to store the user information. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. It has been not copied. So I'm copying it. It is copied. Now open the Anaconda prompt. It has been opened. Give the command cd, give the space, paste the copied path, and now click on enter. Here you can observe, right, current directory is changed to the code folders path. Now compile app.py file, so give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. Just wait for a while. App.py file is being compiled. So here application has been hosted. So this is the local host and this is the port. This 5000 is the port. Now copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here. Click on enter. So this is a web page of the project which is displayed in the browser, and this is developed using Flask framework. So now we have to log in first. So click on login. And if you are registering newly, we have to sign up first and then log in. So you need to enter all the registration details and sign up, and then you have to sign in. I have already signed in. I have already signed up, so I'll directly sign in. Give your username and the password. So I'm giving my username and the password. Now click on sign in. We have signed in successfully and we are redirected to classification page of the project. So here we will be doing classification and detection. So first let's do classification. Click on classification link. Here you can see a choose file button, right? We need to click on that for uploading the fish images. So let's click on that. So let's open the sample folder. As we're doing classification, open classification and open fish A folder. So let's upload this image. Click on open. It has been loaded. Now click on upload. So here the given image, it will be pre-processed at the backend. It will be fed with the train model and then train model will be giving us the prediction. So here you can observe, right? This fish has been predicted as fresh fish in the pink color. Let's upload some more. So let's upload this one. Here also it has been predicted as fresh fish. Let us upload the last image from this folder. So let's upload this one. So here also all the fishes have been classified as fresh fish. Now let's upload images from the other folder. So now let's upload this image. Click on upload. And here you can observe, right? This is a non-fresh fish. So this is a fish that we have given and here it has been predicted as it is non-fresh fish. Let's upload some more. Now let's upload this one. So here also it has been predicted as non-fresh fish. You can observe difference between fresh and non-fresh, right? So it is completely pale here. Here you can observe there are flies on the fish and here the eye is very dull. So these features, they will be considered by the algorithm and then it will classify whether it is non-fresh or fresh fish it is. Let's get back. Now let's do the detection. So click on detection. Click on choose file. So these are the images that we will be uploading now. So let's upload this image. Here also images will be processed at the backend and then train model will be giving us a prediction. So here you can observe, right? A fresh fish has been detected. You can observe that fish is very fresh and the application is also correctly detecting as it is a fresh fish. You can see a bounding box is drawn around it and given the probability score for that. Let's upload some more. So now let's upload this fish. So here also you can observe, right? It is a fresh fish. So now let's upload. So let's upload this one. And here we got the prediction that it is a stale fish. That means it is not the fresh fish. You can observe a bounding box is drawn around it. And here you can observe with the eyes that this is not looking fresh. And the application is also correctly detecting that it is a stale fish. That means it is not the fresh one. Let's upload the last image for this project. So let us upload this one. And here you can observe there are multiple fishes detected and that multiple fishes are fresh fishes. Let's upload last image. So now let us upload this one. So here you can observe, right? Two stale fishes have been detected. This is one stale fish and this is the other stale fish, which means they are not fresh. And now let's check with the graphs. Click on graph. So here we have the graphs. So this is the classification graph for 80:20 ratio where the data is split into two sets. One is 80 for train and 20 for validation. And these are the models trained. And here in this graph, x-axis contains accuracy score and on y-axis we have all the algorithms that are trained. And here we have precision score. This is the recall score and this is FN score. And here we have graphs for data split into 70:30. This is the precision score, recall score, FN score. And here we have detection graphs. This is the precision confidence curve graph, the recall curve graph, F1 confidence curve graph, and here we have confusion matrix. This is the precision score comparison graph where all the YOLO models are trained for detecting, and this is the recall. This is the mean average precision. Mean average precision and recall are used for evaluating the detection models. Accuracy, precision, recall, and F1 score are used for evaluating the classification models. Now click on sign out. Log out. So in this way, just by uploading images to the application, if we want classification, it will just tell whether it is fresh or not fresh. If we want to do detection, it will identify the fish and tell that it is fresh or not fresh. So this is the difference between classification and detection. In detection, it will be localizing the object, and in classification, it will just tell whether it is fresh or not fresh. In detection, it will highlight where that region is. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.